Hey guys, Mr. H here. I am going to do question number 32 from the August 2024 Algebra 1 Regents exam. Essentially what given us is a system of inequalities. They want us to graph it. They want us to label the solution set. And then we got to answer this question here. It says, is the 0.22 a solution? Justify your answer. Now, we could do this part first. We could store 2 into X, we could store 2 into Y, and then we could type in both of these inequalities. And if we get 2 true statements, then that means it is a solution. If we get any false statement, then it's not. Now, you can do it that way. For instance, if you struggle with the graph, you can still get 2 points by doing this and then explaining what you did. But we're going to graph it, and then we're going to look at the solution set, and we're going to plot the point to see if it's in there. So the very first thing we're going to do is we are going to grab our graphing calculator. Now, we're going to be graphing, but we have to graph, we can't graph these as functions, we're going to graph them as inequalities. So the way we do that is you can delete the equal sign, go to option 6, and then you're just going to type in the inequality, 3x minus 4, press enter. That's what it looks like. One of the things I want you guys to pay attention to, when I hover over this line, it has like little blue dots. It's not a solid line. And that's because this is going to be a dashed line because this doesn't have an equal sign underneath, right? So it says y is greater than 3x minus 4. So, all right, now, what I like to do is I like to graph these lines one at a time. So first thing I'm going to do, I don't have the advantage of using a table. Whenever you use relation, there is no table. So got to understand that. But what we can use is menu 51. And menu 51 generally is going to try to give you the y-intercept. So the y-intercept is 0 and -4 for this first one. So that's what I'm going to do. I'm going to put in 0 and -4 on my graph paper. So I'm going to go 1, 2, 3, 4. It's going to be right here. Okay. Now I need like at least one more point for a line. So what I can do is I can just put in an X value and see if it's, yeah. So a -1 is a point. So let's go and plot that. So 1 over down 1. All right. Now let's go ahead and get a couple more. So let's do 2. Let's see what we get. So that's 2, 2. So I can plot that as well. That's going to be 2 over and 2 up. Now you get my point. It looks like it's going up 3 over 1, up 3 over 1, up 3 over 1, down 3, back 1, down 3, 1, 2, 3, back 1. So now I can, actually I'm just going to leave this because this kind of looks like, whoops, this kind of looks like it's dash. Right, it's not going to be a solid line. Actually, that kind of messed it up, but now I'm just going to do the shading. That's the shading. So that's the first inequality done. I checked it's not a solid line. I plotted some points. Now let's do the second one. So I'm going to press tab, and then I'm going to type in x plus 2y is less than or equal to 6. Press enter, and that is it. Now I'm going to go, I don't want this blue one. This right here is the solution set, but what I want to do first is I want to plot this without the blue in the way so I can get some points. So I'm just going to go tab, and then I'm going to go up to the very first one, and I'm going to click on this box, and now the blue one disappears. So now all I have is the red. So let me change the color. And now we're going to do menu 51, find a couple points on this line. The y-intercept is 0, 3, so go up 3, 1, 2, 3. I didn't show you what I was doing. So I went up 3 and I put my point there. Now let's get another point. So we're going to do menu 50. Well, actually we could just put in, let's just put in a X value, see what we get. So it says X 2.5. We need We don't want decimal, so 2, there's a point. 2, so let me plot that. So watch what I do. Now, we already have a point there that's blue, but I'm going to still put my point there. So we go over 2, up 2, so it'll be there. So it looks like it's going down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, up 1, back 2, oops, up 1, back 2, up 1, back 2, up 1, back 2, up 1, back 2, up 1, back 2. All right, so down 1, up. So it looks like I've got that. Now notice the difference. When I hover over this line, you don't see any dashes, you don't see any dots. It's a solid line. So that means that my line has to be solid. So I'm going to take my ruler and I'm going to do the best job I can, make it go through it. All right, that's not bad. So I'll just leave that. Now I got to do the shading underneath, and I'm going to do perpendicular to the line or perpendicular-ish to the line. All right, now this area where you see the blue and the red overlapping, this is the solution set. So we would put a big Superman S there for solution, and that's it. So if I did this with the shading, with the dashed lines, with the points, this would be 2 points. And to me, it's an easy 2 points because all you're doing is just finding some points and drawing your line or dash line, and then you're shading. Right now, we got to answer this question. It says, is the point 2, a solution to the system? Well, let's go plot it. I'm going to make it green. Start from the origin, go over 2, up 2, so it's right here. Now, most of you would probably say that this is a solution, but it is not. And the reason that it's not is because it's on this dash line, which means that it's not included in the solution set for the first one. So like if you plug that in, let's say y is greater than 3x minus 4. So watch this. If I plug in 2, that means the y value is 2. 3 times 2 is 6. 6 minus 4 is 2. So is 2 greater than 2? It's not. So this point is not a solution for that first inequality. So that means we would say no, it's not a solution because it's not in the solution set. And technically it isn't. It's not in solution set. It's right on the boundary. So it's not. That's it. That's how you do it. That's what you're doing. I hope I've gone into a lot of detail, but I hope it was helpful. There's a bunch of ways to check to see if this is a solution. You can plug the point in for both of these inequalities and see if you get true statements, or you can actually graph it and then check the graph. And unfortunately, it falls right on the boundary of this dash line. If this line was solid, it would be in the solution set. But because it's a dash line, it's not in solution set. All right, I think I beat that horse to death. I'm going to stop and post.